Have you ever seen a news report after a huge downpour? You'll see one river that's turned into a raging, destructive torrent in just a few hours, while another one, maybe just a few miles away, seems to have barely noticed the rain. Well, that difference isn't random. It's actually a story told by the landscape itself, and it's a story we can absolutely learn to read. So let's dive in and figure out how to understand the narrative of a flood.
So this is the big question, right? This is the mystery we're here to solve. What is it that makes one river a ticking time bomb ready to explode and another one this kind of slow, gentle giant? The answer, it turns out, is all about how a river's surrounding area, its basin, responds to a storm. And the main tool we use to read this story is called the storm hydrograph. Now I know, graph sounds boring, but trust me, it's not just some chart with lines on it. Think of it more like a river's diary or a play-by-play of its reaction to a storm. It shows us all the drama as it unfolds, from the very first drops of rain to the absolute peak of a potential flood. Okay, so here's our game plan. First, we're going to break down the river's storyline itself. Then we'll look at the anatomy of that rainstorm as it shows up on the graph. We'll compare the two totally different ways a river can respond, and then explore all the natural and, importantly, human factors that write the script. And finally, we'll see what this all means for our future. All right, so to really understand the story, we've got to learn the language first. Let's deconstruct one of these hydrographs and look at all the key moments in a river's life during a storm. You know, every story has a beginning, a middle, and an end, and a hydrograph is no different. A river just starts out at its normal, chill level, which we call base flow. Then boom, the rain hits, and you see the water level start to climb. That's the rising limb. Now this next part is absolutely crucial. There's a delay, the lag time, between when the rain is at its heaviest and when the river actually hits its highest point, the peak discharge. And if that peak goes over the bankful discharge line, well, that's when you get a flood. Finally, things calm down, and the falling limb shows the river getting back to normal. Okay, but not all stories are the same, right? A hydrograph can show us two completely different plots for a river. One that's super fast and dangerous, and another that's slow and way more manageable. This is really the core conflict here, the flashy versus the subdued response. And this right here shows the difference perfectly. A flashy river has a really short lag time and a super steep rising limb, which leads to a crazy high, dangerous peak. It's like a sudden, almost violent reaction to the rain. A subdued river, on the other hand, it takes its time. It has a long lag time, a gentle slope up so the water level rises slowly and the peak is much, much lower. And the flood risk between the two? It's night and day. So what decides which path a river follows, which story it tells? Well, it all starts with the natural landscape. That's the stage where this whole drama unfolds. These are the physical factors that really set the scene. First up is the drainage basin itself, the area of land that drains into the river. Think of it like this. A small, compact basin is going to collect water and shoot it into the river really fast, making it flashy. A circular basin is like a perfect funnel. It's super efficient at concentrating that water. But a long, stretched-out basin, that gives the water a much longer journey, spreading out the flow over time and creating a much more subdued, calm response. Next up is the network of streams and smaller rivers that feed the main one. If you have a high density of these tributaries, it's like a superhighway system for rainwater, just whisking it directly into the main river channel. That shortens the lag time like crazy. But with fewer tributaries, that water has to kind of find its own way over the land, which slows the whole process down. Now, what's under our feet is also a huge deal. I like to think of it this way. Is the ground a sponge, or is it a shield? Permeable rock, like sandstone, acts like a giant sponge, soaking up a ton of water and reducing how much actually runs into the river. But impermeable rock, like granite or really dense clay soils, they act like a shield. Water just can't get through, so it rushes over the surface, straight into the river, and bam, you get a very flashy response. And finally, there are two other big natural characters, the slope of the land and the plants growing on it. Steep slopes are basically a water slide for rain. It just moves incredibly fast. But dense forests and vegetation, they act like a natural brake system. Their leaves and branches catch the rain, a process called interception, and their roots help the soil absorb it. It is a powerful, powerful force for creating a much more subdued, less dangerous hydrograph. But here's the thing. Nature doesn't get the final say in this story. We, as humans, have become the primary authors of the flood story. We often end up rewriting a river's natural, subdued script into something way more flashy and, honestly, destructive. And the biggest rewrite we make comes from urbanization. We essentially replace those natural sponges with concrete shields. Our roads, our roofs, our parking lots, they all prevent water from soaking into the ground. And instead, we build these incredibly efficient drainage systems that are designed to do one thing: get water into the river as fast as humanly possible. The result is a textbook flashy hydrograph just waiting to happen.
Just picture it. In a totally natural landscape, rain falls, it's caught by trees, it soaks slowly and gently into the soil. It's a whole system perfectly designed for absorption and a nice, slow release of water.
Now, let's swap that out for an urban landscape. That exact same rainfall hits concrete and is immediately funneled into a drain. There's almost zero interception, almost zero infiltration. That water is essentially put on an express train to the river, which dramatically, and I mean dramatically, increases the flood risk. And it's not just our cities, you know? Chopping down forests has pretty much the same effect. It robs the landscape of its natural sponge. Even certain farming practices can compact the soil so much that it starts acting more like a shield. And when we straighten out river channels to make them look tidier or more efficient, we're actually creating a bobsled run for floodwater, speeding it up and just pushing that flood risk onto communities further downstream. So you see, understanding the hydrograph isn't just some boring academic exercise. It's about reading the signs. It's about understanding the very real risks we face and recognizing the massive impact of the choices we make on the landscape around us. So if you take away anything from this, let it be this: the hydrograph is the river's storyline. A flashy plot means a high flood risk. And while nature sets the original scene, it's our actions, paving over landscapes, removing forests, that are turning so many of our once calm rivers into these dangerous, flashy characters. So we now have the ability to read and understand this story. We know what makes a river dangerous. The question this leaves us with isn't really whether we can predict floods, but what are we going to do with that knowledge? Are we going to keep writing a story of increasing risk? Or will we choose to write a different, smarter, more sustainable role for ourselves in the next chapter?